Hey everybody, video number 10. Today we are going to learn how to balance chemical reactions, and balancing reactions is one of those rite of passage things in chemistry. One of the very few things that anybody who's taken this course remembers that they need to be able to do. So let's get right into it. I'm going to do it at the board because I'm going to do some writing. But first, let's just talk about what exactly is going on. First off, matter cannot be created or destroyed. It can only be simply rearranged. So that is the law of conservation of matter. And then so we're going to use that to balance these equations. So the stuff that's on the reactant side must be total on the other side. So all the atoms must be accounted for. If I have 4 carbon atoms on the reactant side, I have to have 4 total carbon atoms on the product side. They got to equal because it can't be created or destroyed. I can add whole number coefficients to balance the equation, and that's all I can add. If I put in subscripts, well, that will change the reaction itself because I'm changing the molecules. We're not allowed to do that. All right, and then these coefficients, when I'm all done, have to be reduced if possible. Sometimes, because there's a certain element of trial and error to this, I can have all even numbered coefficients, and then if they are all even numbers, then I can divide by 2. Right? So I need to make sure they're in reduced form. That's the last piece. And so here's a quick example of an unbalanced chemical equation. I see 2 H's on the reactant side. I see 2 H's on the product side. I see 2 O's on the reactant side. I only see 1 O on the product side, so it's not balanced. Okay, we'll balance this in a minute once we learn how to do that. Okay, moving on. How do I balance them? So first, I list the elements involved one time under the arrow. That's how I do it. And then I said that's going to end up being like the net in a tennis game, and we're going to go back and forth, counting and changing. So then I count up how many of each element in the reaction. And if it's a reactant, I put it on the left side of those letters I put. If it's on the product side, I put it on the right side. And you'll see when I do this. We're going to have to do a few so you get a feel for it. Okay, and then I can see which one I need to fix, ones that aren't equal. So I can change the mole coefficient in front of the element or compound that has that element in it to balance it. So once I do that, then I have to reevaluate. So then I have to recount based on the number I did. I put in a number, it changes every element within the molecule, recount up what's going on my whatever side that was, and then reevaluate which element do I need to do next. And then that's it. We stop when we are all even. So let's go to that first example. This was the example that was unbalanced before. And I'm going to take you through the whole process. Ready? Watch. I'm going to write down the elements. I have H and I have O. Now I'm going to count them up. On the left-hand side, I see 2 H's. And on the left-hand side, I see 2 O's. And on the right-hand side, I see 2 H's. And on the right-hand side, I see 1 O. So I don't need to start with the H's. I need to start with the O's. And what am I going to multiply 1 by to get it up to the 2 that I need to get it by? And that is 2. So I religiously have to put the coefficient in first, 2. And then I redistribute to recount. So now I have a total of 4 H's and 2 O's. So I fixed my O's. My oxygens are now balanced, but do you see that I unbalanced my H's by accident? That's okay. We can just rebalance. I see that there are 2 H's here in this group. So what do I need to multiply 2 H's by to get it up to 4 total? I need to multiply this by 2. So this will get me up to 4 H's. I can get rid of this. And now 4 and 4, check. 2 and 2, check. This equation is now what we call balanced. And then for the beginning part, and actually for the most of this whole unit, I'm going to request that you put the 1 in there. I won't mark you wrong if you don't, but there is a multiple choice question that the Regents likes to ask. And they say, the first one is, okay, when this is properly balanced, what is the coefficient in front of H2O? And so then you'd obviously pick 2. But then the other one that they ask in other years is, when this equation is properly balanced, what is the sum of the coefficients? And in that would be 2 plus 1 plus 2, which is 5. And you know 4 is going to be an answer choice. So I'm going to request that you put the 1s in so you get that one question right every time after you're done balancing. And now we're just going to do a bunch of examples, and then there's practice for you to do, and you can do it. So let's work out some examples. So an example with a polyatomic ion. First things first, we keep the polyatomic ion together. So here we go. If I see NO3 on both sides, keep it together as a single element. It makes life easier. So underneath the arrow, I'm going to list Al, Ca, and I'm going to keep NO3 together as a single element because it's on both sides. It's here and it's here. So because it didn't break up, I'm not going to break it up. It makes it easier to balance. Trust me. So on the left-hand side, I have one Al, I have one Ca, and I have two NO3s. And on the other side, I have one Al, one Ca, and three NO3s. Ooh, this one's going to be fun because I need to fix 2 and 3. Okay. Well, I can't just multiply 2 by 1.5. And if I multiply 2 by 2, I get up to 4. Notice I can multiply it by 3 and get it up to 6. And if I do that, I can get the 3 on the other side in red up to 6. So that's what I'm going to do. I'm going to multiply the left-hand side by 3 because I want to get that NO3 up to 6. But I have to reevaluate. That does change my CAs, right? So that puts a 3 in front of the CAs. And that puts a 6 in front of my NO3. So I can cancel those out like this. And then to get my NO3s up to 6 on this side, I'm going to put a 2 and go like that. And so now I'm going to have 2 ALs and 6 NO3s. Now my NO3s are now balanced. Fabulous. And that was complicated. They're not all that complicated. That one was much more complicated than normal just because it wasn't 2 and 4 where I just had to double the 2. Okay, this one had a greatest common factor piece. Our greatest common multiple. So now to balance out CAs, I got 3 on the left, so I need 3 on the right. And when I do that, that's a 3, which is nice as lone elements. And same thing with AL, I'm going to do a 2 there, so that this becomes 2. And now they are checked. And I cannot reduce those because there's 3's involved, so I can't reduce those coefficients. Beautiful. We got one with polyatomics. Done. Okay, example, synthesis reaction. CaO2 with CO2, okay, or CO, so let me write my elements down. And I got 1 and 2 and 1 and 1, so I instantly need to multiply this one by 2 to get that up to 2, but it also makes my Ca2, and I put a 2 in front of my Ca, and I am balanced. I'm going to write these over in red because I don't know how well they're showing up for you. I think red shows up a little bit better, and that's a 1. Okay, now that one is balanced. That's a synthesis reaction. Okay, let's try a decomposition reaction. We learned about the different reactions. So I'm just giving them the names that they deserve. All right, I got P and I got O, 2 and 5 on the left, 1 and 2 on the right. Okay, I've done these a bunch. I can't just put a 2 on the P because the 5 is all messed up. And the 5 is a problem because I say I have an even number on one side and an odd number on the other side. So I know that I have to do something like maybe multiply these two numbers together. So 10 would be a good one to get those up to where they're both equal 10. So I'd have to multiply this by 2. And then my P's will go to 4 and my O's will go to 10. And then if I did that, I would multiply this one by 5. That would take me to 10. Perfect. And then what do I multiply my P's by? 4 to get that up to 4. Perfect. Balanced. Balanced. So 2, 4, 5 are my coefficients to balance this particular equation. I know I'm going quick, but I don't want the video to be 35 minutes either, right? I want you to be able to get through it. So, all right, I see a polyatomic ion, single replacement. Notice NO3 and NO3 stays together, so I'm going to keep it together. I got Ag, I got NO3, and I got Ca. Counting them up, 1, 1, 1. CA's is 1, NO3's is 2, AG's is 1. So notice I have to fix that NO3 right away. I'm going to multiply 1 by 2. So I have to religiously put that here and now reevaluate. This is Ag goes to 2, NO3s goes to 2, so I'm good with NO3s. I have to fix Ag, multiply him by 2, get him up to 2, and then put in my 1s, and I am balanced. Because there's 1s, I cannot reduce any further, and this is balanced. And I think we have maybe one more. Let's see. One more. Double replacement polyatomic ion. Okay. So that's okay. I see I got NO3 on one side and NO3 on the other side, so I can keep that together. I have sulfate on one side, sulfate on the other, and keep that one together. Let me list my elements. Na, NO3, Ca, SO4. Good, counting them up. 1, 1, 1, 1. Ca is 1, NO3 is 2, Na is 2, SO4 is 1. Okay, let me go ahead and fix my Na first. Multiply 1 by 2. We'll make this go to a 2, and my NO3 go to a 2. Yo, check it. Check, 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 check. That was easy. And this is balanced. Put in my 1s, and we are good. So this is going to take a little bit of practice. I will tell you that they only get complicated when you have something like oxygen in multiple, like a lone oxygen in multiple molecules. That happens. Then when I change one, I gotta add them both up, and it takes a little bit more time. When I have lone elements, I try to save those for the end because I put one number in front of that element and it balances the equation. Where when I put a number in front of, say, NaNO3, it affects both things. We got lucky that on this particular problem that's what we need. We need to fix both of those things. But a lot of times that's what creates the ping pong effect where we got to keep going back and forth and back and forth. And that's okay. We just keep going until it's all balanced. And I'm hoping that we are done. All right. Have fun balanced equations, guys.